Hi, guys. Welcome to my YouTube channel. This is Jayesh, and today we'll be covering hashing algorithms or cryptographic hash functions. We'll see what are different type of hashing algorithms are and what are the applications of it. So the first thing about hashing is that it is a one-way function. So if you have doing encryption, it is both way. So you can convert this into ciphertext. You can go back to plain text. But in case of hashing, you can only use it to create a message digest and you cannot go back. This property allows us to prove the integrity of a message. So avalanche effect, so a small change in input results in significantly change output. So let's say if I have 4 bit, right? 4 bit, for example, 0, 1, 0, and its message address came as, for example, 5. Just for these examples. And if I have made a small change, the new message digest will be entirely different. So this is a property of avalanche effect. So input of any length means you can enter how many bits you want, like 1024, 512, whatever, and the output will be of same length. So if you are using SHA 256 algorithm, so if you enter 512 bits as your input, your output message digest would be 256. So if you are using 1024, it will be same. Similarly, 2048, all of this, it will be 256 bit. Okay, so it should be easy to compute for its properties and it should be collision resistant. Collision resistance means is that two hash functions, sorry, two plain text cannot have a same hashing function. So if I'm using, for example, let me show you. So if I'm using, let's say, I have this application, app one, and its hash is 2041, and I have second application, its hash is also 42, but this is collision. So a good hashing function should not allow collision. So hash function should be unique for every text that or every message that you are computing for. Similarly, so types. So this will come up in your security certification exams like Security Plus, CYSA, CASP, CC, CISSP. So like I have given few of the certifications and I saw few questions from here. So if you are seeing, so MD5, just remember it is not secure specifically in the organizational environment, but you will still see on if you're downloading something from GitHub or you're downloading an OS, you might still see MD5 hash there. So it is prone to collision attack. As such, 160 is also not used. So a collision attack was successful against it. So in exams, you might get questions like how much message digest size is for a given algorithm. So it's simple. In SHA, it is 160 bit. In MD5, it is 128 bit. And in SHA2 family, the name represents what message digest size it would be. So SHA2 is considered secure. So 256, 512, 224. So 224 and 384 are based out of these two. So these two are used as much as the rest of them. Like 257 vital depends on what you're doing, but ideally, a lot of times you will just see 256 and 384. And SHA3, so it requires a more computational power. It is secure than SHA2, but it requires computational power. So if you have the power, then you will use for it, like for hyper more computational power devices like supercomputers and things. But if you have a smaller devices, let's say for example, let's say a laptop or something, anything that has a low computational power, you ideally opt for SHA2. So similar to SHA2, it gives you 224. Instead of what it will do is you will get like this SHA3 224, SHA3 256 similarly. So instead of 2, you will just get to replace the 2 with a 3. So these are the types of hashing algorithms. So there are other also like break, and there's also Haval, RIPE-MD. So there are other, but I think most of the time you will see these two also, these two. ideally, or most of your examinations, you will see this now. So that's an application. So digital signature is one of the most important application for this. So we'll be seeing in next video what digital signature is. So in briefly, so when you want so it is used to provide repudiation, non-repudiation, and authentication. So and integrity. So what you will do, let's say this is a message, you will create a hash of this message, which is this one. And when you are sending a message, you will send message plus hash to the other person, and the other person will create a hash of this message h2, and what he will do, he will verify if h1 equals to h2. So hash, if they match, then the message was sent for you. And what one more thing what you will do is you you will encrypt this h1 with the hash with your private key so that nobody else could change it. See, this is a brief overview of what digital signature is. In our next video, I'll explain it in more details. This is using password hashing. So your HC, shadow files, and all those different things, the way organizations store your credentials. So when you log in into, for example, Facebook, you will see your passwords are stored in a hash form with sorting or pepper. So in sorting, you add random bits to the password, just password, and in pepper you add a large constant number. This is the difference, but most of the time we just use sorting. So sorting will help you prevent rainbow attacks, rainbow table attacks. This is this, and file and data identifier. So this is used in to verify if the file is same as that was sent. You might have seen if you download any application from GitHub, you will see it asks you to verify the checksum or the hash functions if it is same as a sure data. Or another one is in if you download some sort of applications, it is different from code signing, but it is also another application. Sometimes they also share you a hash function. So when you download it and install it, you can match for it if the hash function is matches the same that was sent to you. These are some of the applications of file of hashing functions. So majorly these are used. There are different ones like proof of concept and all those different things, but ideally most of the time you will see these three things. So with this, our session comes to an end. Thank you for watching, guys. Make sure to like and subscribe and comment down your thoughts. And if you want me to cover a certain specific topic, as always, peace out. Thank you.